My dear students, good morning to all. Today we are going to learn about reactivity towards hydrogen for 16th group elements or Chalcogens. First, 16th group elements are oxygen, sulfur, selenium, tellurium and polonium. Okay, polonium is a radioactive element and the remaining elements are known as Chalcogens. Due to these elements are available from ores, that point is based on these elements are known as Chalcogens. And next one, melting points and boiling points of 16th group elements. These elements are observed on moving down the group. Melting points and except oxygen, this is exist gaseous state in nature, and the remaining elements, melting points and boiling points are means on moving down the group, melting points and boiling points are increases. So last two elements, tellurium is exhibits more boiling point than compared to polonium. Okay, these elements are observed on moving down the group. Boiling points are increases. So last elements on moving down the group like tellurium and polonium, these two elements are observed. Tellurium is exhibits high boiling point then compared to polonium. Why? What is the reason? Polonium is a radioactive element. Okay. So this is the introduction to 16th group elements. And next one, these 16th group elements react with hydrogen to produce related hydrides. For example, oxygen react with hydrogen to produce H2O molecule, and remaining elements react with hydrogen to produce related hydrides like H2S, H2SE, H2T. Okay, polonium is a radioactive element. These are the hydrides of 16th group elements. Okay, some important properties are observed these molecules. These hydrides are observed on moving down the group. These hydrides are observed on moving down the group. First property, reducing character. Reducing character is increases. Reducing character is increases. Generally, group elements are observed on moving down the group. Reducing character is increases. That is the general trend of group elements in modern periodic table. But these hydrides are observed on moving down the group. The nearest atom is hydrogen. So that point is based on these hydrides are observed on moving down the group. Reducing character is increases. And next one, acidic strength is also increases on moving down the group. Acidic strength is increases on moving down the group due to Ka values are increases on moving down the group. These hydrates are observed on moving down the group. These molecules Ka values are increases. So that is one of the important points. And what is the reason for these hydrates are observed on moving down the group? Acidic strength is increases. Generally, these molecules, oxygen, sulfur, selenium and tellurium, size of the atoms are increases. The nearest atom is hydrogen. This is exhibits electropositivity character and electronegativity character. Okay, so these hydrides are exhibits electronegativity character. So these molecules are observed on moving down the group. Acidic strength is also increases. Okay, that is one of the reason for these hydrides are observed on moving down the group. Acidic strength is increases. And next one, boiling points. Boiling points. These hydrides are observed on moving down the group. These hydrides are observed on moving down the group. First molecule H2O is exhibits highest boiling point then compared to others in the respective group of hydrides. Okay, H2O is exhibits highest boiling point. Highest boiling point. These hydrides are observed. H2O is exhibits highest boiling point due to this molecule is exist liquid state in nature. This molecule is exist liquid state in nature. And next one, H2S. H2S. H2S is exist low boiling points than compared to other molecules in the respective group of hydrides. H2O is exist high boiling point due to this molecule is exist liquid state in nature generally. At ordinary conditions at room temperature, this molecule is exist liquid state in nature. But H2S gas is exist gaseous state in nature at room temperature conditions. At room temperature conditions, H2S is exist gaseous state in nature. Okay, so H2O is exist high boiling point and H2S is exist low boiling point. And next one, stability of the given molecules. Stability. Okay, stability of the given molecules. Generally, these molecules are observed on moving down the group. Generally, these molecules are observed on moving down the group. Stability is decreases. Stability is decreases. Stability is decreases. Stability is decreases. These hydrides are observed on moving down the group. Stability is decreases. Why? What is the reason? Stability is decreases. Why? What is the reason? For example, H2O, these hydrides like H2O, H2S, H2SE and H2TE. These are the hydrides of 16th group elements. So all molecules, hydrogens are same. Hydrogens are same. These are the small size of atomic molecule. And next one, the nearest atom in the given molecules are observed: oxygen, sulfur, selenium and tellurium. So these nearest molecules, the nearest atoms in the given molecules are observed: oxygen, sulfur, selenium and tellurium. So these atoms are observed on moving down the group. Sizes are increases. Sizes are increases. Sizes are increases. Sizes are increases. So sizes are increases. Sizes are increases. So these atoms, the nearest atoms, oxygen, sulfur, selenium and tellurium, these are observed on moving down the group. Atomic number is increases. Atomic number is increases means electron cloud is also increases. Electron cloud is increases, size of the atom is also increases. But the nearest atoms, hydrogens, are similar. These are the small size atoms. Okay, so small size atom bind with oxygen. Oxygen is also small size atom. Some stability is there, but on moving down the group, size of the atoms are increases. Size of the central atoms are increases for the given molecules. So size of the atoms are increases, but nearest atom size is stable. Size is do not increases. Then finally, the bond strength is automatically decreases. So bond strength is automatically decreases. Bond strength is automatically decreases, then stability is also decreases. That is a explanation for stability of hydrides for 6th group elements. Okay, finally, these hydrides are observed on moving down the group. Stability is also decreases. Okay, this is the explanation. And next one, bond angles. Bond angles. These hydrides are observed on moving down the group. These hydrides are observed on moving down the group. Bond angles are decreases. Bond angles are decreases. Why? What is the reason? So these hydrides are observed on moving down the group. Bond angles are decreases due to so many reasons are there. But simple reason is size of the central metal atoms are for these molecules or increases. Size of the atom central atoms are increases. In these molecules, central atoms sizes are increases. That is a simple reason. And another one is electron donating capacity for the central atoms are automatically decreases. Okay, that is another reason, and so many reasons are there, but these are simple reasons. So these hydrides are observed on moving down the group. Bond angles are decreases. Finally, these hydrides are observed on moving down the group. Bond angles are decreases. Bond angles are decreases. Okay. These are the explanation for reactivity towards hydrogen for 16th group elements. Finally, once again recalling these points. So first one, 6th group elements react with hydrogen to form different types of hydrides like H2O, H2S, H2SC and H2T. So these hydrides, some properties are observed. Generally, these hydrides are observed on moving down the group. Reducing character is increases. And next one, these hydrides are observed on moving down the group. Acidic strength is also increases. These hydrides are observed melting points and boiling points. H2O is exhibits more boiling point than compared to others, and H2S is exhibits low boiling point than compared to others. Okay, these hydrides are observed on moving down the group. Stability is decreases, and these hydrides are observed on moving down the group. Bond angles are decreases. Okay, next we are going to learn about reactivity towards oxygen. Generally, sixth group elements like oxygen, sulfur, selenium, tellurium and polonium, these elements react with oxygen to produce two types of oxides. One of the category is MO2. MO2, and another one is MO3. M means sixth group elements. Okay, for example, sixth group elements like sulfur, selenium, tellurium and polonium, these elements react with oxygen. These elements react with oxygen to produce different types of oxides like MO2 type and MO3 type. First one, these elements react with oxygen to produce MO2 type of oxides like sulfur dioxide, selenium dioxide, tellurium dioxide and polonium dioxide. Okay. So these are the MO2 type of oxides. And next one, these elements are react with oxygen to produce MO3 type of oxides. MO3 type of oxides like SO3, sulfur trioxide and selenium trioxide, SCO3 and tellurium trioxide, TeO3 and polonium trioxide, POO3. Okay. So first I am going to discuss the properties of dioxide. The properties of dioxide. So sulfur dioxide, selenium dioxide, tellurium dioxide and polonium dioxide, these dioxides are observed on moving down the group. These dioxides are observed on moving down the group. Acidic strength is decreases. Acidic strength is decreases. So SO2 acidic strength order is SO2 is exhibits more acidic character than compared to others. And next one SCO2 and TeO2. Last, polonium dioxide. This exhibits basic in nature. Why? What is the reason? Generally, 16th group elements, oxygen, sulfur, selenium, tellurium and polonium. Oxygen and sulfur, these are two elements are non-metals. These are non-metals. And selenium and tellurium, these are metalloids. These are metalloids. And polonium is pure metal. Polonium is pure metal. Okay. So these dioxides are observed. Sulfur dioxide is exhibits more acidic character than compared to others. Okay. And next one, these dioxides are observed on moving down the group. Reducing character is also decreases. Reducing nature is decreases. reducing nature is decreases. Okay, so first one, so these oxides like MO2 type of oxides, MO2 type of oxides, these are the MO2 type of oxides. MO2 type of oxides are observed on moving down the group. So these are observed on moving down the group. Acidic strength is decreases. Acidic strength is decreases. This is the order of acidic strength. And next one, these are observed on moving down the group. Reducing nature is also decreases. Reducing nature is also decreases. And next I am going to discuss MO3 type of oxides. MO3 type of oxides. MO3 type of oxides like SO3, SeO3, TeO3 and POO3 means sulfur trioxide, selenium trioxide, tellurium trioxide, polonium trioxide. These are also observed on moving down the group. These are also observed on moving down the group. Acidic strength is also decreases. Acidic strength is also decreases. The first oxides are exhibits more acidic character, and finally on moving down the group, acidic strength is also decreases, means basic strength is increases. So this property is also similar both oxides like MO2 and MO3 type of oxides. Next one, these trioxides are observed on moving down the group. Reducing nature is also decreases. This property is also similar both oxides like MO2 and MO3 type of oxides. Finally, these two oxides properties are similar, but what is the difference between two types of oxides like MO2 type of oxides and MO3 type of oxides? Okay, so these two oxides are observed, MO2 and MO3 type of oxides. So the acidic character is different. The acidic character is different. In these two oxides, acidic character is different. So MO2 type of oxides and MO3 type of oxides, two types of oxides are taken. MO3 type of oxides are exhibits more acidic character than compared to MO2 type of oxides. MO3 type of oxides are exhibits more acidic character than compared to MO2 type of oxides. Means sulfur trioxide is exhibits more acidic character than compared to sulfur dioxide. Okay, so this is a explanation for oxides of 16th group elements. Finally, recalling these points, so these oxides are observed, two types of oxides are there. First one MO2 type of oxides and MO3 type of oxides. These two oxides properties are also similar. These are observed on moving down the group. Reducing character is decreases. First molecules are exhibits best reducing agents, and final one, these are exhibits best oxidizing agents. For example, so first molecule is exhibits best reducing agent. Finally, these molecules are exhibits best oxidizing agents. Okay, so acidic, these are observed on moving down the group. Acidic strength is decreases. Okay, so next one, finally both properties are similar, but what is the difference between two types of oxides? So MO3 type of oxide is exhibits more acidic character than compared to MO2 type of oxides.